Okay, so Mahendra is he's a systems architect at Huawei, and he's going to talk to you about one of the most interesting things, I think, in IPv6, which is segment routing. You know, one of the things, it's an intriguing area, but I'm always wondering about all the security. Sure. You know, I mean, obviously, right? Obviously, it's like really, how are you going to do this? And so I really would love to have him tell us how he's going to do it. He's also worked with MPLS.
Reflected onto the access link, and you shut down the access link. Oh.
Okay. Oh, thank you. And Mahendra, if you could start off and tell everybody a little story about how you got involved with IPv6 and with the IETF, that'll be great. And then just so you know, the timer is right there, that right next to Drew. Thank you so much.
Good morning, everyone. Well, my name is Mahendra Negi. I work for Huawei, and my current work involves design and developing SRv6 stack and applications. So, as how I got involved in IETF is around 3 years back. I started off, reading the drafts. Basically, I was involved in PCE group. So I started, finding some erratas starting with, and then slowly, picking up the new ideas and writing draft. Basically, Dhruv mentored a lot, so thanks for that. So we could still these drafts. I mean, still the work is in draft stage, not yet adopted as well, but is going through. So that is what it is. Well, today's my topic is about segment routing in IPv6. I'll start with firstly to see segment routing in very brief, what it is, what is the idea. Then I'll talk about why IPv6, segment routing in IPv6, that to be called SRv6 in short. Then SRv6 network programming concept, and SRH header, like we need SRH, one IPv6 extension header to achieve the programming or SRv6. So that also I will talk about how that is actually encoded in packet and processed. Then some use cases. So first thing is the head node, the source node decides how the packet is moving. Means there are certain instructions, or we call this path, is embedded in the packet, and the packet is pushed across the network. And those instructions are actually executed by the nodes in the network. Like if you see in this example, the packet goes from A to H. H is the destination if you see. So it goes via C, G, and then H. So A is going to forward the packet to C. C understands the instruction, what it is already programmed in C, then executes to G and H. It doesn't send it to D. Maybe the best path is D, but you have programmed to send it to G and then finally goes to H. So the path can be computed by your static policy or by your some algorithm, or it could be computed by controller as well. So as already talked, injects the path in the packet header, and the subsequent nodes forward the packet based on SID or the instruction. So there are two instances we have, SR over MPLS data plane. It reuses MPLS data plane, and the other one is SRv6. It uses IPv6 data plane with the SRH extension header. So, well, advantage of segment routing. First, we see before segment routing, we were using source routing using say MPLS TE, RSVP TE tunnels. But this has you know, the scalability issues like the network grows, your number of P's grow. You have what do you call the network states grow in that because you have signal involved. So, that way now that state whatever we were moving whatever was there in the network node, now we have moved to the source node. So, source node is having the instruction or that particular control information and that embeds that thing in the packet. So, with that we avoid LDP and RSVP TE complexity, means we can simply eliminate the protocols and run the service over SRv6. So, as the complete state is moved from network to packet. Reliability wise, we have topology independent LFAs. So, that we will see how we have one use case there, and pretty much it can be applicable to all the networks. Why SRv6? I hope future is IPv6 networks. So, I mean that is what is the building block. So, the next is if you want to achieve SLAs, traffic engineering, your reliability over IPv6 network, you need to have SRv6. Yeah, I mean that I do not want to build again that on MPLS or RSVP TE. So, I would rather go for some new technology which is not having those issues.
Yeah, my name is Shraddha. I had a question on SRv6, especially what do you think is the motivation for people to move to SRv6, which requires a different forwarding plane? I mean, you pretty much have to replace your current hardware to the new hardware which supports SRv6, whereas you can natively do IPv6 in SRMPLS itself. You have ISIS. ISIS can do IPv6. It can advertise SIDs for IPv6, and you can do MPLS and traffic engineering and whatever you want. You will be able to achieve it using SRMPLS in IPv6 only networks.
Yes, yes.
So what's your thought on what would be the motivation for operators to move to SRv6?
Few things are there, like programmability is enhanced in SRv6. Like I told, right, MPLS has like limited scope in the programmability aspect. I have one slide on that. Maybe I will talk on that.
Okay.
Because the thing is, in MPLS level, if you see, right, you have very few functions involved in that. But if you see SRv6, the function you can embed anything you want it. So it depends on your use case.
Yeah. So MPLS, it's the difference is just with the labels, right? You do whatever you want, you can do in MPLS with labels, and you achieve the same with IPv6 addresses.
I'll just show you another slide. Yeah. So this I listed some of the differences. I mean,
sure.
Basically two aspects. One is simplicity, and another one is programmability.
Okay, sure. We can see the slide, and then maybe if I have questions, maybe.
Yeah.
Thank you.
Well, just brief the difference between
Sorry,
SRv6 and
sorry, Mahendra. Just have a very basic question.
Yeah.
Hope people will not laugh at me. Yeah. So see, this is source-based routing, right?
Yeah.
So we have age-old concepts, strict to source routing, loose source routing, and we can do that using hub-by-hub header in the IPv6, IPv4 as well, right? So this is what is the thing extra?
I didn't get the question. If you could elaborate
So segment routing is a new technology, right?
Yeah.
Based on the source.
Yeah.
So you pre-compute the source through which the packet has to go through, right? So why do we need this technology? We already have age-old concepts. I'm very new to segment routing. Age-old concept like strict source routing, loose source routing.
Yeah, that is what I told. For that,
that
is what I told at the beginning, right? We have source routing. One way to achieve is using MPLS TE tunnels, right? So, but that has cost involved in the sense it has certain signaling involved in that. It is not straightforward like, and that is not so scalable as well.
Okay.
So for that reason, we avoid all these complexities using SR.
Okay. Computation of the path is
Computation of the path
that
is
is
same,
uh-huh.
but the thing is the signaling, right? That is before you say for MPLS TE to work, you need OSPF like for reachability, right, or ISS for reachability.
Okay.
And you need what do you call even for the labels to distribute, right?
Okay.
You need LDP or RSVPT.
Okay.
Now what we have done in this is IGP itself can propagate labels as well.
Okay.
So those issues like LDP sync and signaling, state maintaining at every node. Like if you start a tunnel from one node to another node, right?
Okay.
So that at every node you maintain some state. Like this is this tunnel. I have to forward the packet like this.
Okay.
So that is avoided.
It is built in this protocol itself.
Yeah,
so
it's embedded in this.
okay. Thanks.
Just to add to that, like SR did not invent source routing. Source routing always there.
Yeah,
It's just a
already it was
new
there.
mechanism. We are not claiming that this is
We are
this is the
reusing
new this thing. It's just a new way of doing something old. That's what we like to do in ITF anyway.
So one more point I just wanted to, just ask you that in SRv6, if you see the header size, when you are going ahead and ahead, your headers increases like anything.
Yeah.
So what is that take on that particular thing? If you see, compare.
That's pretty obvious question actually. I will say that is open-ended question. In fact, I don't have any answer to that, but if somebody
I have a
wants to
question.
comment. Yeah.
See, this is a new. Sorry. This is a new implementation because most of the service providers they have a legacy equipment. So they are running, IP. They're very good to go with the IP and MPLS. So they, any payload on the BGP, it's fine. It's capex or opex, it is not much high. So what is the benefit I get it from implementing this? And there's a lot of existing solution which can work on this problem. What is the problem statement? Okay.
Maybe I've got some slides. You can go through.
No, you're just comparing that because that's the one through. Okay, fine.
Just on the fourth row, I want you to elaborate what do you mean by simple in terms of layering of labels? Because as I understand, the latest draft of SRv6 still talks about encapsulation mode. I mean, you have outer IPv6 header in which you insert the SID list. So this is also stacking, right? So you put
It's stacky, but only SRv6 is, the IPv6, what do you call, the SID is used. There in that case you have, you have BGP involved, you have VPN label. I have some slides, we go through that. Yeah, actually I have the materials.
It's Adrian. I don't want to derail you, but are we on this slide at the moment? Or because you flipped forward. No, he wants to go backward. Yeah, if you want to go back to do something else, but when you are on that slide, I want to say some things.
Okay, sorry. Thank you. Okay, well, the difference, what I'm showing is it's simple and it's pretty programmable as compared to SRMPLS, as most of the people were saying, right? So now I will just go on programmability part.
Well, you did put that slide back up, and I just have to pick it apart because.
Sorry.
That one. Yeah. So SRMPLS works with an IPv6 control plane. The data plane is MPLS only. There's no IPv4 in it. The complexity, I would really argue, you need the same number of items of information, with the exception of the network programmability, where you can embed stuff. But if you're talking about the root, the source root, you need the same number of items in the stack for MPLS or for SRv6. The interworking with legacy network, actually, the MPLS to SR-MPLS interworking is really easy. It's been shown to be easy. It's, I think, implemented easily and it's documented. Network programmability, we already know is easy. For example, layer 3 VPN. You know, I'm finding this slide kind of hard. It's like you've got a message, SRv6 is good, and you're going to tell us that regardless of
Actually, that is the idea. Okay, now with the programmability aspect, see the program is nothing but set of some instruction, right? So how the program instruction is defined, and it is network, so it has to be advertised across, and finally it has to be the program has to be constituted after out of these segments or the instructions. So that is what I will show first, like how the program is created, we call in SR the segment list, how that is created, and then how we inject that into packet, and how the the nodes, the source node, the transit node and the end node behaves to those instructions and the packet when the packet is received by that. Well, the program instruction we call here is segment identifier, and the program is nothing but a segment list of these segments. It has two parts, locator and function. Locator actually routes this particular this segment to the node which will act on that, which will perform some function on that. So that is the locator part, and another one is function part. The function is like you can pretty much encode any function you want, any function you implemented. Yeah, this is the list of SRv6 functions. It's a fade, but I have reference, so you can go through that reference. So lot of functions are there. Like simplest could be just pick the packet, forward it to next hop, like IGP next hop, or pick the packet, send it to particular adjacency, like the particular link. So that kind of functions could be there. And another thing could be like okay, use this VRF. The function is like, okay, this is for particular VRF. So that kind of functions are there. I have use cases, we will show further. So now how that is embedded in the packet, I have SRH extension header. As people already talked, like its size may grow, so it's there. So that argument just like depicting how the SRH is encoded in packet. And here the important part is this segment list. This is nothing but my program I was talking about, and segment left. This is the part which will tell which segment to use, like which segment to use to perform a function, because the segment has involved one function involved, right? So the segment list will segment left, this index will tell which function to perform when packet is received. Well, how this program is constructed. So the first control plane, which all control planes are there, IGP, BGP and controller. So pretty much the SID or that particular instruction can be allocated or can be configured by any of these ways, and it is distributed across the domain, across the network. Yeah, so now the SIDs are distributed across the network. Each node knows about the SIDs. Now segment list could be done by controller, or could be computed by source node, or it could be static way. So this is the program, like list of functions, list of my SIDs. Now we see how the packet is forwarded based on this program or segment list. I'll just skip this. Yeah. So the first segment to execute, my source node forwards the packet to the next segment, which is R1 here, and R1 has the function, because R1 has advertised that function, R1 knows what is that function involved in that. So it performs the function. The function is pretty simple here, like you have to just forward the packet to R2. Again, R2 knows the function, on this particular, the segment, the next segment is moving. Now you see what is the function involved in R2. Yeah, pretty much like you have to just forward, like it's very simple function. So like this way packet travels. Now I talked about SRH because SRH is used to encode the segment list or my program. So for that, how source node behaves, like source node will insert the segment list or the program in packet and then forward to the next segment. So here I have segment list and the packet is routed from A1 to A4. This is nothing but my locator, and A4 is my the last endpoint. This is in reverse order. It is encoded in reverse order, and segment list set to -1 and -1. Sorry, yeah. So packet is forwarded based on the destination address. Destination address we pick from segment. So A2 is, if you see, A2 is set as a destination. Forward and the packet is like one transit node is there in between, which doesn't support SRv6. So what does it do is it simply forwards the packet to A2, which is the destination. There is no change in the no SRS processing here, just the packet is forwarded based on your IPv6 forwarding. Now at another segment where the A2 receives the packet, and A2 is like again you decrement the segment length at that and it is now and the next address is set to A3 and SL is modified, decremented and forwarded packet to A3. A3 does the same thing, all the way goes to A4. A4 rips off the packet and performs the action involved. That action involved could be anything like send the packet to the next C or something like that. Yeah.
So can you go back to the previous slide? So here the insertion of this SID list, is it happening in the IPv6 header of the original packet from the source, or is the payload inner packet from the original? So my understanding is the payload is the full original packet from the source, and all the things that you do is on the outer header.
See, this packet comes, right?
Yeah.
This is the packet, right? So 1 minute, sorry. Yeah. Yeah.
Yes.
So SRH is inserted here. That SRH is there, right? So this SRH is nothing but having the list of segments.
No,
that is
my question is different. So A1 is the node which is inserting the SID list, right?
Yeah.
But before AN, someone originated the packet,
Yeah.
IPv6 packet.
Yeah.
And that full packet you
That is nothing but
contain
payload.
as the payload.
That is
right?
nothing but
Okay.
payload.
Mahendra?
Now-
Sorry. Yeah. So, two questions. How do you deal with the tunnels and per packet load balancing? Do we have such use cases?
Load balancing is in
Per
this.
packet load balancing and how about tunnels in between?
We have
like,
ECMP, right? So it will just go based on ECMP, like normal IPv6, how it goes, like normal IP.
But path is already computed, right?
Path is computed, but path is computed, but the thing is, I mean,
Or we don't encourage ECMP in case of.
ECMP
We
is
may
that
not
because
encourage,
if
is
your
it?
path is strict, right? Here, I mean, path computed, you mean is path is strict, right? If
So
path is
that
strict,
question may not come.
that question doesn't, I mean.
Okay, so yeah, there is one thing. So
yeah.
other thing is how about tunnels in between we may encounter tunnels, right? Any kind of tunnel, we don't know.
Yeah, that's what, any kind of tunnel, if any kind of tunnel is there, right?
So that will be
how,
taken
how
care
do
in-
we
yeah.
achieve that using SRv6? That's what
yeah.
I am just showing in this
Okay,
slide.
okay.
Yeah, say any tunnel is there, right? Like your GRE and you know, you have any overlay like GRE or VXLAN for that matter. So now I have this simple topology. If you see this one, I will just take this as a like this is the starting point and this is end point. Yeah. So I want to achieve overlay over this network. Like as you told, right, what tunnel is there, say from R1 to R5, right? So for that I reuse BGP to signal the next hop at the source end, right? So source end knows the next hop. What is the next hop for this particular prefix? Like say X2. That I want to reach X2. For X2, and next hop is A5 F1, but this A5 F1 has this function involved. Like this is nothing but SID, SRv6 SID, which is already advertised by IGP in the domain. Now he wants to send a packet. Say if R1 wants to send a packet to R5, you have next hop there, and packet reaches to next hop, and next hop knows what function I have to do on that, and it simply cross connections packet to X2. Is that okay?
So inside that tunnel there is no segment routing.
Actually, there is no tunnel. I'll show you how it goes now. Say IPv6 packet came, right? I just need.
What I mean to ask is inside the tunnel there is no.
There is no.
It is
tunnel,
traditional switching.
There is
inside
no
the
tunnel.
Whatever
Like,
tunnel.
as such, no tunnel. I mean, no signaling. Like if you say
Okay.
tunnel, right? There is no nothing like that. So it's like because the instructions are there already in the nodes, right?
Okay.
Yeah. So
So
in this
instructions
case,
are there, so that they will talk about tunnel. So which is tunnel endpoint, which is.
endpoint here is like.
Let me try. If I tell me if I'm mistaken. Your question is there might be an existing tunnel in the system, and the SR wants to use that existing tunnel, and so that can be possible because these are just functions. You can define a function which says that if you receive this SID list, send on this tunnel, which could be a GRE tunnel or this thing. So everything gets tunneled through like a normal tunnel. That doesn't change anything. That still remains the same.
Okay.
Yeah, it reads up the IPv6 header and packet is destined to X2. So I mean there is no tunnel to configure here, no SRH encoding involved because the stack is just like one segment. Yeah, now the simple case with your underlay SLA like low latency path, the service requires low latency path. In that case, source will compute now the segment list, right? So again the segment list is here, it's via A4 to A5. Like BGP says this is my next hop. Now SLA, he has to achieve one tunnel or one segment list. He has to compute a path which satisfies this latency, and the path goes via R4 like this. So this that kind of tunnel is set up here, the path is set up, your packet progresses, SRH is encoded in packet at source node, moves. Yeah, next like you eliminate overlay protocols here, like simply you use BGP, and underlay is already taken care by IGP. When it knows like the service requirement, it computes the path as per SLA. It does suppose TE as we saw, like latency path, and like it can run over any VPN like L3 VPN or eVPN for that matter.
Yeah. I have a question. I am Annapurni. So in the previous slide, right? So where is SR coming into picture?
In this?
Yeah,
one,
about the
this is SID, right?
IBGP, yeah.
This is SID. This is SID and this is function involved. This is locator, this is function involved. The function involved is for this particular
No.
router.
But this is like normal, if we have V6 and then we have BGP, right? How is it different with SR here? I mean, I see it as a normal IGP plus BGP, IBGP, right?
You are right. There is nothing new here because there's no SRH extension. Only difference is that what A5F1 would means that this A5F1 may not be a routable IPv6 address. This must be a SID with, which is understood by R5, and R5 would have used some SR extensions in IGP to flood that information. But in the data plane, it's just IPv6. Nothing changes.
In fact, this is IPv6 address only.
In this case, sorry, I'm wrong. It has to be routable. Sorry. My mistake.
Reliability. I am talking about, yeah.
Hi, my name is Jayesh, actually from Juniper. Actually, I have a question in previous slide.
This one?
Yeah, we are getting something from, like I didn't get the concept, like BGP is giving you next stop AY F1. Like we have to change in BGP also, like the function which is it is going to.
It's like normal MPLS VPN, right?
Yeah.
It's same. There is.
But like the F1 function, I didn't get how will.
SID.
Okay.
So like VPN SID, BGP extension is required for like VPN SID. So VPN SID is encoded along with this next stop. Yeah, this is normal path, primary path. The topology here is like this is normal path, and now I want to show R1, the router R1 is configured with the TI-LFA, so it has one backup path pre-installed. Say the link goes, now packet is to be rerouted towards R4 and cross connected to R5. If like cross connect function, I mean is there is no routing involved at this router. It simply forwards packet to R5. So this C5 is that function. Like otherwise normal routing, what happens? It will this one will do routing. So if routing is there and it is not converged, the packet goes back here and forms loop. So for that reason, the function involved here is like that matters. Well, it supports it provides SRLG, node link failure, 100% coverage. It's like L3 VPN case, same thing as you told, right? The question. So here, so this is what is you have to configure this function in BGP and signal to the other side. Same thing. Just moving the slides.
Just to answer that question, this is Dhruv. BGP signaling kind of remains the same. What has changed in the L3 VPN is you are not using MPLS label thing there. You are using SRH extension header to identify exactly the same thing. What was identified by a VPN label, but is now being identified by a specific IPv6 address. That's the set.
Like one attribute you are adding. One more attribute is added along with the next stop, whatever BGP sends to the peer node, right? In that, one attribute is added, you can think of.
So one generic question regarding the use case. This is Dinesh Sivaraj from Juniper Networks. Just like to reiterate what Shraddha had asked earlier. So some of these are very generic use cases related to source routing, and it can be addressed by MPLS, SR MPLS as well. So we were interested in knowing, Shraddha asked the same question, what is the motivation behind, what is driving some of the SR-V6 requirement? For example, in DC environment where we have pure IPv6 underlay only, and where we have requirements like egress path engineering, where like you want to, from a server you want to exit to a specific exit node, I mean say, and even in case of service chaining where you want to, in the underlay, like on a specific hop, you want to, say, hook it onto a service functional to be applied. And are there such requirements? Are there such very key market requirements being driven, which is kind of driving this SRv6 implementation, so which requires a new data plane support?
Actually speaking, there is no such requirement as of now to us. I mean, we hope requirements will come in future, and so that is what we are working on. I mean, as of now, there is no such requirement as, frankly speaking, that is what.
Thank you.
And I have another slide for that. I mean, I'll just.
That was a really fair answer, and I think that it's fine. Okay, one of our jobs is to come up with cool tools and then see what we can hit with them. So that's great. On this specific point, I'm concerned that what you're doing is overloading the concept of an IP address. So currently an IPv6 address is defined as identifying an interface. End of story. So you're proposing to change that. There is an option called the destination option, and effectively what you're doing here is taking something that could be in a destination option, and in the design of IPv6 was supposed to be in a destination option, and you're squidging it into the v6 address, and therefore I think possibly setting yourself up for a disaster 5-10 years down the road when the IPv6 address space is depleted.
It's a big address space, right?
No. The assumption on all of this, though, is that the address can be split into a routable part and a semantic part, yes, where the destination option says, that's okay, put the routable bit in the address, put the stuff that's only supposed to be processed at the destination in the destination option. And in fact, v6 gives you the ability to have two destination options in a packet. One for the ultimate destination, which is kind of the L3 VPN case, and one for the next hop destination, which gives you the service function chaining capabilities. It gives you many of the things that the network programmability draft is trying to do, but it does it without breaking architectural concepts. So you get the same function, you're still using a v6 only network, although I'm not sure that many service provider networks that are deployed don't actually have MPLS. But anyway, if you've got a customer that says, I must have v6 only, you could do all that without breaking v6.
Stick around, Adrian.
Guys, I'm just going to do a logistical thing. We've got 4 minutes until the next talk, so I'm going to cut the mic line.
Okay, so I agree with Adrian 100% that you got to be very careful about encoding semantics into addresses. But I just and we have a lot of experience where that has caused problems in the past. That having been said, the one caution about what Adrian said that I just want to highlight is that just as in IPv4, in IPv6, hop-by-hop options are not exactly considered the most popular things on earth.
One basic question. Yeah, this is Sridhar from Juniper Networks. Yeah, basic question. What was the thing which was not possible to do in the previous one which you are trying to solve through this?
You mean SR MPLS?
Yeah.
MPLS cannot run everywhere. I mean, flatly speaking, MPLS cannot
No. I am saying even before that, with the source routing and with the OSPF TE and other things, you were able to solve all these problems, right?
But you had cost involved there. Like you are running, RSVP TE sessions, LDP sessions keep on running. If your network grows, those things also grow. Like it's not scalable.
No, it is not even required to have RSVP TE, right? Even with OSPF TE and other things itself, you will be able to do that. No, I am saying, is there any basic thing which was not solved by it, which you are trying to solve through this? That's the basic thing.
This is one thing, that complexity you are, avoiding. Your network, whatever the states you are maintaining in network, that is avoided now. That is moved to ingress, right? Yeah. That is one thing. Okay.
Guys, please. I know, please.
Just a quick general question. General question. The question. See,
I know. I'm going to be like
the problem is how do you interop? In service provider, it is not a greenfield. So they have a legacy network. and they are running very good. Hey, it's good with MPLS, with LDP or RSVP. So the problem is how you are handling the downward compatibility. See, if I have to introduce your system into as a new deployment, how I going to work with the existing environment or the downward compatibility? Whether any thought on that?
I know.
Actually speaking,
thank you.
Yeah.
Yeah. Finish up and then because we have about 2 minutes. No minutes. No minutes. Yeah.
Okay, this is what I wanted to show. Like flexible algorithm. As of now, we are talking about having some policy configuring on source router and all. Now, what is happening is that policy or the constraint is going over the network, and everyone knows about that particular policy or algorithm. And each node in the network, not like this will work as the algorithm is defined, not like normal IGP wherein you have to go based on the least cost path. So here what happens is you are working on these constraints. So I have defined one locator and one algorithm. So this algorithm says I need this path, that is signaled over IGP, IBGP. This node knows now, seeing the flex, like what kind of path this particular service requires, right? So it downloads like that. Here I have this routing part is different if you see. So so these two paths are different. See, this router does not support say one flex. This router supports both the flex, so it can download this next hop, but this can only download next hop for the brown one, not for the green one. So like that you can slice the network as well using flex algorithm.
Okay, guys, really, I'm sorry.
Okay,
you guys need to listen.
Just a minute.
Oh my God! I know, really, one person. You must know my kid. I know, I've lost all control.
Okay, well, this is about slicing part. You can slice the network based on these SIDs, what you would call seeds. So for one slice, you are giving one seed. So as flex algorithm, you can define flex algorithm 1 seed 1, flex algorithm 2 seed 2. So like that can be sliced. Okay, I'll just
Yes,
I'm done.
Okay. You guys, he'll be around. You can ask him all kinds of questions. Okay.
More use cases are there.
Yeah, he's got more use cases and yeah.
And
okay, good. Okay, all right. So
thank you very much.
Yeah. Thank you. Okay, let's give him a hand for being.